All right, let's get started. So welcome everyone, and thank you for joining us for our November Weiler Wednesday webinar. My name's Chad Honstein. I'm Creative Services Manager for Weiler Abrasives. Today I'm joined by Rick Hopkins, our Senior Product Manager here at Weiler, Mike Beecher, co-host of Weld.com, and Brian Logaglio, welding instructor and adjunct professor. Today, these three industry experts are going to discuss improving the quality of multi-pass welds with brushes and abrasives. Before I begin, I just want to share a few tips with the Zoom webinar platform. So we've muted all lines to prevent background noise. If you have any questions, feel free to use the Q&A function. And we'll answer those questions as time permits. You'll see some polls pop up on your screen throughout the webinar. We invite you to participate and answer those questions as they relate to you. Finally, if you're using the Zoom app, we recommend switching to the gallery view so you can see all our speakers on screen at one time. On a desktop, you can do this by clicking on the view icon in the upper right hand corner, and on your phone you can just swipe left. If you're using the browser version, you'll still have a great experience as well. And before we jump into the webinar, just a couple quick updates on our response to COVID-19. So as we continue to manufacture around the globe and help critical industries that need our products through these challenging times, as we get back into the field, I just wanted to share how our field sales team has been engaging with our customers and our distributor partners. We're doing that virtually, just like we're doing today. We're conducting virtual training events for spot safety, and we're troubleshooting applications to provide solutions to our customers. We're also back in the field in many areas where it's safe. We're following local and CDC guidelines related to social distancing, wearing masks, and sanitizing to make sure that we stay safe and that we're coming to your facilities in a safe way. So please don't hesitate to reach out to us if you have any if you need any abrasives expert support. We can do that both remotely or in person at your facility. So with all of that said, I'm now going to hand it off to Rick to get us kicked off here.
Thanks, Chad. Yeah, and again, everybody, I'm Rick Hopkins, and I'm one of the product managers with Weiler Abrasives. But I'm really excited that we figured we'd change things up this month, and rather than you hear everything from the manufacturer's perspective, I'm really pleased and excited to have Mike Beecher from Weld.com with us, and Brian Logaglio from he laughs at me, right? So he will be from Now. Brian L. From now on, but I did my best. So Brian's the lead welding instructor at Marchman Technical College, UA welding instructor for the local 123 down in Tampa, and an adjunct professor at Hillsborough Community College. And then in addition to all that, in his spare time, he's also a journeyman steam fitter and welder. And I've had the opportunity to work with him, and I know that Brian also spend some time with the guys at Weld.com as well. So again, guys, really appreciate you being here and spending some time with us to talk through the ways that people, any user, any welder, any helper, any user can get the most out of their abrasive safely and effectively.
Thank you for having us.
Yep, thank you.
Yeah, so now really quickly, we always like to start our webinars off with safety, and so this is obviously no different. And so today, just wanted to talk briefly about the importance of guards, and certainly, I'd love to hear your guys' thoughts and opinions and perspective. But and again, a reminder: we're not a tool manufacturer. We're not at all affiliated with tools or anything. But obviously, right, the guard is arguably the most most important piece of safety and protective equipment that puts and creates, it's designed to be a barrier between you and the workpiece. And proper positioning and installation of this guard is critically important, no matter what abrasive or wire product that you're using. And so, so often in the conversations that I have, the guard gets a bad rap, right? It's always in the way. It's always, and my contention and my personal experience is that, for sure, never assume that a tool that you pick up or a tool that somebody hands you, regardless of what their skill level or expertise is set up and positioned appropriately for you, right? So take the time to consider the way, the positioning, how you're going to attack the workpiece and approach the workpiece, and make sure that you take that time to appropriately position that guard again, right? So that it's a barrier between you and the workpiece. So many things can happen in a second's notice, right? And they're called accidents on purpose. And again, right, it's so critically important that we're all taking the time to make sure that we're starting with the right foundation and making sure that that guard is properly installed and positioned.
Yeah, there's a lot of things I see, Rick, is people standing in the way and just let grinding sparks hit them right in the stomach, chest. I mean, they don't even know. You got to go over there like the helpers or someone starting out. Even with experience, they'll just need to walk over there and say, hey, step to the side. The grinder's going to kick back. It could hurt you. Even with a guard on, you got to be aware of what you're doing. And also that guard where it like curls up right here, I see a lot of people modify that and chop that off for some reason. Or they take a channel locks and bend that back a little bit. That's a no-no. Don't ever do that. You know what I mean? And also, I see people. I had an incident when I first got into the welding world. I didn't have the guard on. I was cutting a tack, and it had a lot of pressure on there from we were welding on it. And the cutoff wheel jammed and it kicked back and hit my leg. And I was too scared to even tell because I didn't want to lose my job because I had bills. And if that guard was on there, I would have been not having, like I had like 6 or 7 stitches. And, I wouldn't have that if I didn't. That scar reminds me forever. But, and also I see a lot of people with them trigger locks on there. Them are very dangerous too.
Headman switches.
Yeah.
Grinder safety I always kind of laugh at it because I've been doing this for 15 years. I work for multiple entities. Safety is number one, and every grinder I have at my house or my shop has a guard on it. And you'll see someone that's new, as soon as they buy a grinder, they'll pull it off and throw it in a garbage can. If I've been doing this for as long as I have, not that I'm, been doing this for 20, 30 years, but if I've been doing this at a professional level as long as I have, why do I use it every day? And, newer people don't. So, and then why we do all this, like, we're not welders because it's a hobby. It's a way of life. It's a livelihood for our families. And it's getting to the point in the industry that if you don't have a grinding guard on your grinder, you're not working at that facility. And sometimes, and it's becoming more of a standard that first time offense, you will be banned from that facility. Certain like power generation entities will no longer have you on site anymore because that is a major safety point to them. And now you're affecting your livelihood. And now that could trickle to the contractor you're working for. Now you're affecting their ability to bid work with that entity. And, this isn't, like I said, this isn't a hobby. We're doing this to make a living. And I'll keep that guard on to keep making the money I have.
Yeah. Yep.
Yeah. Well, and the thing that I've always said is a guard, right, it's like kickboxing without a cup, right? You can get away with it for a while, but eventually it's going to ruin your day, right? And so, again, not to belabor it, and we absolutely want to get into the meat of this conversation, the reason that we brought everybody here, and that's really to talk about actually welding failures, more importantly, how to avoid them, and most importantly, how the decisions that we make, the preparation that we put into the thought and preparation and the steps that we take throughout the entire welding process can have a significant effect on that weld failure, right? And so you know, both Brian and Mike have been nice enough to provide some visual aids, right, to show some of this in action. And so, you know, I'd like, you know, Mike, if you wouldn't mind to talk through you know, what you've done for us as far as this you know, the visuals and what we're doing here, and then, you know, let's just get right into it and start walking through the process and what you did to get to the end.
All right, so what you guys are looking at right here, right now, are carbon steel 3/8 plate, but these are the end result of when you weld up your joint or weld up your test, them are your test strips, about 1.5 inches. But you see that little low spot right there in the middle of your screen? It looks like a fingernail, like shape of a fingernail. Well, that's from not grinding your stop out. If you don't grind that out, you won't have a good tie-in. And also, if you see that right there, that's either Slag Occlusion. Actually, that looks like what is it? Slag Inclusion. That's from running over your slag. Like people always say, "Oh, just turn it up 5 or 10." You know what I mean? Burn it out. You ain't gonna burn it out. You know what I mean? It's gonna cost you your job and cost you your money. But yeah, I mean, that's the start of that. But let's start from the beginning. It's very important to always remove your dross. You got your dross here on the side from the plasma. If you don't remove that, let's say you're doing TIG welding or even stick, the puddle don't be as fluid. It won't react to you. If you move left, it's going to be a little sluggish. And also it's going to show up on an x-ray like porosity a little bit. You might not even see it. Here's more of a better example of dross. You see that right there? You want to get that off. You won't be able to weld over that really good. So the type of wheels I always use is a hard rock. So I'll go over there, clean up the plate, get it all nice and clean, remove the mill scale, inspect it, make sure we're all good to go. Then I move over and bevel my, I usually bevel my plates to a certain degree. You have to do a certain degree according to the WPS if you're working to a nuclear code or a commercial shop with a WPS. It's very critical to get to that grinding angle.
Hey, Mike,
so I usually use a, oh, sorry.
One sec. That let's talk about, before you get too far, that dross, if it alloys into your weld, that's also, dross is very hard. It's
yeah,
you know, a heavy carbon deposit. So
yep.
it's very likely that you will end up causing a crack over time of service. So you grab a pipeliner disc that won't skip around and you get everything off. And that dross has to get off there. I just wanted to touch on that real quick. I didn't mean to interrupt, but
no, good point. Yeah, I mean, he uses a pipe liner for that. I use a pipe liner when I'm in a bevel or doing a pipe. I like to use the hard rock right here.
Yeah, so let's just talk real quick for a second about the difference, right, between a pipeline wheel, right, and again a hard rock or a 1/4 inch grinding wheel, right, and why you know, you, Mike, prefer a 1/4 inch grinding wheel, and you know, Brian, I'd love to hear why you choose and have always leveraged the versatility of that 1/8 inch pipeliner, right? But talk about the differences in the wheel, right? The difference in the control, the versatility, and the ways you use them, and why a little bit, why you like what you use.
There's a couple of reasons. Let's start out with that 1/4 inch hard rock. What we mean by 1/4 inch is the thickness. It's going to me, it lasts a lot longer. You're going to get more bang for your buck out of it. So that's one first reason. Also, there's a nut. I love that nut. I always lose my nuts.
Yeah.
But when you're grinding, let's say you're in a bevel of your weld. A bevel is a plate put together, and you're inside that bevel right here. Let's say you got to be real narrow. In code, you can't take away that bevel. They'll like tell you cut it apart, reshape your bevel. So that wide wheel would destroy your edge of your metal. You have to be in tight tolerance. This is why I use it, and also on the dross. There's actually reasons for each wheel you want to use. To me, there's reasons. Pipeliner, if I'm working in a real tight spot, I'll use a pipeliner. I got different reasons, different wheels for different reasons. I mean, that's my opinion.
Reason I would pick up a pipeliner is, one, I'm throwing one rock or one rock like abrasive on my grinder, and now I can prep. I don't have to worry about my grinder jumping around with the pipeliner. And then if I need to touch on anything on the inside, like my root pass, if I need to touch anything, I can also notch with that one.
Yeah. It's good for notch.
But the main thing about it is I find what the pipeliners, my opinion is, they don't jump. And my background's all code work, and I have to maintain, original thickness of material and not cause a base material repair. That's just more paperwork and so on. I just have had a lot of success with the pipeliner of not jumping around and being very versatile, where that one disc can do multiple things for me.
Yeah, for example, like let's say running your cap and you don't want to destroy your cap. I mean, that's your last steps you got to do. And the pipeliner won't jump around. You're being more accurate, because if you mess up your cap and you get a base metal reduction, your BMR, or you mess up your bottom bead of your cap, I mean, you're screwed. I mean, that makes your weld look ugly, and a lot of places won't even let you have no grinding marks on top of your weld or anything. So yeah, I mean, that's actually the main reason I use that pipeliner all the time.
Yeah. So now, Chad, if you wouldn't mind, showing the video of Mike beveling the actual piece here, right? And Mike, talk about what you're doing and how you're doing it, right? You talked about the importance of setting that setting the edge, right? Setting that initial bevel, and then working in, right? And so, right, again, right, what kind of tips can you give users and operators about the way to achieve that accurate, consistent bevel, the more quickly and more easily. And then, right, the other thing that I want to talk about is, and we'll talk about it in a second, is the fact that you go in and you finish up with a flap disc, right? So let's talk. I'd like to have you walk through that process and what you're using, what you're looking for, and the way you're actually using the product.
Yeah, so I usually throw the hard rock or the 1/4-inch grinding wheel on first, and I don't work the whole piece of metal because it's counterproductive. I want to work a little bit, get myself set, get the right angle, and carry that all the way down. If I just do that whole thing at once and I didn't even check with my degree finder right there with all the numbers you see, well, I could grind it at the wrong angle, and that whole piece might be junk because I don't have no room to make up that, to correct myself. Sometimes when you're not doing nuclear code, you'll have to weld that back up because there's no more material. So I usually take a hard rock, get my rough it in, and get it all roughed in almost perfect. Then I use a buffing pad or tiger paw flat disc. I usually, I like to step it up with a little bit finer grit. I use the 40 grit there, but I like 60 grit, and I'll kind of fine tune that, make it all nice and straight, make sure my angle is right on the money. It's not no concave or anything. That's what you want. I mean, when you're doing code work, it's got to be on the money. I mean, you're really tight tolerance. If you're not on the money or within that 1/8 inch, they won't let you go ahead and weld that joint up or go ahead and tack it up. So that's the reason I do it that way. And I even do my land with I usually do it with a hard rock. I mean, not hard rock, a buffing pad. I just think it looks prettier. I mean, with finer marks, you can see what's going on, how the light hits it. You actually see, I think you can see better indications and better flaws when you have a finer finish on there.
Yeah. How about you, Brian?
Honestly, every time I've beveled a piece of pipe, if I have it available, I want to use a Type 29, Tiger Paw, and I will do that from knocking down a square edge to laying it back. And while you're showing that 29, the great thing about that is this taper. A lot of people like this concept of never bevel with a tiger paw was kind of told to me when I was young because it always roll the edge of pipe. And once you swap over to the 29, that doesn't become a thing. And more times than not, we were TIG welding our root passes. So I always, like Mike just touched on, is you can see all the imperfections. While I'd be prepping plate or pipe, I'd be coming around, keep spinning it, and I can pull that towards me, that disc, and I can keep that bevel going and seeing that consistency. I don't have the different angles, the different grainage in it, and it came out once I was done prepping, done beveling and everything. At that point, I'm ready to weld. I got to touch up the inside, and depends on code and everything, but you know, we grab that one disc and it could prep a pipe for us.
Yeah. Also,
Yeah,
I want to
no,
mention. Oh, sorry.
yeah,
Go
go
ahead.
ahead, Mike. No, no,
So
go ahead.
a lot of people I see a lot. I'm like, hey, go grab me a 40 grit. They don't even know what 40 grit is. Well, if you want to get done fast, you want to get your butt in and out on the job, you want something aggressive. You want 36 grit or 40 grit. What grit is basically, you know, I mean, you'll see a bit very like coursey, bumpy area that will take you lower the number. You'll get done faster and get your job or move on to another job. So that's a definitely good thing. I mean, you want to pay attention. It always says it right here. A lot of welders don't know the difference from 40 grit to 120 grit. They might look at that and say, why is that like that? Why is it got finer? Why does it look finer right here and everything? And also, I see a lot of people holding that grinder at a wrong angle. You don't want to hold your grinder at the wrong angle. You want to do it how the pad is made. The pad always says 0 to 40 degrees or 0 to 15. It's made that way for the best performance and everything. You have to do it like that. I mean, people
also
just
tell you to heartbeat when they're on the wrong angle.
oh yeah, oh yeah,
Absolutely,
for sure.
right? Like, you know, when you're looking at a flap disc and you're seeing that extreme edge wear, right? And practically untouched on the inside, right? Again, right, the main point here is here's two different guys that are both you know, super experienced and have strong preferences one way or the other. There's multiple ways to achieve the goal. You know, regardless of what flap disc that you're choosing, right? Again, right, the point of a flap disc is to use as much of the width of that flap as possible, right? If it's not contact in the workpiece, you're not getting any benefit out of that abrasive, right? So when you're looking at your wear pattern and you're seeing a disc like this, and that, right, to Mike's point, is a great application where when you're grinding with the disc and you're at a higher angle, a steep angle, and you're using that disc, that's the main benefit to these Type 29 conical angled style flap discs, to allow that full width of contact even at a higher, more extreme aggressive grinding angle.
Well,
Yeah.
when you have when you have that footprint touching too, you're more consistent.
Yeah.
You're moving metal the way you're trying to at that point, and you're doing it at a consistent rate. And when you have those discs that are wore out, they're digging just with a tip, and they're, you know, it's wavy.
Yeah,
You
they're
can always
creating
tell.
heat. You're putting heat in your material. Friction, you're just bouncing off the surface. You don't want to do that at all. I mean, you're working against yourself. You're very bad and everything.
Yeah, well, and you know, another analogy that I always use is like, right, like when you're trying to hide a drywall seam or blend anything, right? Do you get better results when you use a real narrow profile, or you widen the profile, right? And by spreading out that contact patch and that footprint, right? It's much easier to get the same result in fewer passes without having to feel like you're constantly hitting the same area multiple times and causing you, right, those gouges, those undercuts, right, rolling your edge in your land, and all of the things that can happen, right, when you spend too much time grinding and get overly aggressive in a specific area.
Sure.
Yeah. And also, when like a lot of people don't know what ceramic is and zirconium, I like to use ceramic because it, you know, I mean, it takes the heat and it keeps on cutting, especially with stainless. It will just keep its like self-sharpening. I noticed it just keeps self-sharpening and it just cuts stainless really good, because when you're grinding stainless, when it heats up, it feels like everything just gets slower. You're removing metal really slow. So ceramics, I think, is the best way to go when you're doing a hard rock or using a flap wheel. I mean, I think that's the best way for, you know, I mean, removing on stainless.
So with that in mind, right, talk for a second, because one of the counter arguments to ceramic is, but it's so much more expensive, right? So talk about the difference between the cost of the individual product and the overall cost of the product, right? The labor, the time that it takes to get the job done.
Yeah, I mean, for example, when you're grinding, the material heats up, or your pad's going to heat up. So it's either going to melt your grit and you're going to lose your grit, and you're working against yourself. All you're doing is bouncing off. And on the long end, even though you might take 10 minutes slower or 30 minutes slower, and you think that pad is like, you know, I mean, is whatever, less cheaper, and you're saving out on the long run. Maybe in a hobby shop, but when a big shop comes, you know, I mean, a big, huge shop or whatever, you're costing money, you're costing time. And you're actually just, you know, I mean, messing off, you don't know nothing. I mean, you got to know what you're doing. And it's better just go ahead and buy that expensive pad and have someone train you how to use it. You will get your job done way faster, and you won't be agitated. You won't be mad. You won't be throwing that wheel in the garbage saying it's junk. It's very important to know, I think.
So 2 aspects. In the field, like I made a premium rate, and we had to show work for that when we were done. So ceramics got us through the job a lot quicker. It knocked down material faster. I buy them for my school now to remove mill scale. And the reason I do it, and talking about a tiger paw again, is I teach all my students how to use a 27, and pull towards them, and they can get a nice shiny piece of metal. And if I was originally buying aluminum oxide, and I believe that's what it is, and they were going through discs very quickly, where this disc might have cost more, but it's so much cheaper in the end. And in a student's hand, over and over again, I can have more students come in and knock down the mill scale, and this disc keeps going. When I was using the aluminum oxide, they were just wearing out so quickly and not getting the product we were looking for.
So right, and it's a great time to talk about what mill scale is, right? And Mike, you've got another great clip about removing mill scale, and again, just one of the things that I hear, right, when I'm out talking to customers and users and operators is a lot of times, let's face it, right? You touched on it. Mill scale can be a real pain in the neck, right? It can be extremely thick, very difficult to get off, and so it's real easy to become frustrated, complacent, right? Move on. And one of the things that I hear is, particularly in the scope of stick welding, is it'll burn off when I'm during the process, right? And so talk about what mill scale is and why it's so important. And again, right, the fact that we're talking about this in the scope of Multipass, everything that we're talking about here holds so true, right? Whether you're talking about stick welding, MIG welding, or TIG welding, and arguably, I've always said that, right, as you get into MIG and TIG, it's even more critical, right, that you're paying super close attention here and getting rid of these impurities.
Yep. Hey, Chad, rewind that where I'm like scribbling on. Oh, here, pause that. That's perfect. So the whole gray part, what mill scale is, that whole gray part, black part right there, or not black, but like dark gray. That's mill scale. Well, that's caused when the metal is at the mill. Well, the metal's really thick, and over time, and it's hot too. Well, they gotta basically put that through rollers, and they basically the rollers on a big press. It just basically keeps thinning that metal out. When it cools, all the impurities comes up to the tops and float. That mill scale, you gotta take it off, because you're going to get hardly no penetration. Well, you won't get penetration with 7018. 6010 you'll get a little bit because it's a deep penetration rod. The reason you got to take it off, lack of fusion, you're gonna get porosity. Your puddle's not gonna be as fluid, especially with MIG and TIG. I mean, MIG is not as deep when you're doing short circuit deep penetration. What I mean deep is like you're going inside the metal, like straight in. You're not, you're going straight in. You're not going to get as deep penetration. It's going to cause porosity again. The puddle's not going to be as fluid. Especially with TIG, it's very critical with TIG. It's very critical with TIG. Your puddle won't even react right. It's like the puddle is like sluggish. It's going to look black and everything. So that's mill scale. So what we're doing is trying to remove the silver part, and get it completely silver, where we can have good, accurate results. If you're not doing that, you don't know what you're doing. You don't care about your work, basically.
So what are you looking for, right? Like a lot of times when you're grinding mill scale, right? Like to me, it feels like the wheel is almost skating across the surface rather than actually biting, right? Spark is much lower, right? So, like one of the things that I talk about is really being disciplined, right? And don't just assume that you're through it when you start to shine up that surface and things start to look more consistent. That doesn't necessarily mean that you've completely cleared that surface of mill scale. And again, all right, I'd like to get both of your thoughts on, right? hard wheel or flap disc or combination wheel or resin fiber disc, right? Like, what do you like, and what have you, what's been your experience as far as tackling mill scale and working with mill scale, and why?
Go ahead, Brian, first this time.
Yeah, it depends on the aspect. If we're just talking about black steel, I'm gonna go for a tiger pawl again. That's been my go-to of removing, and it removes it aggressively. But if you know how to use it, you're not getting into the base material. There's been times that we've had to remove. We'll call it mill scale, but it's more of an oxide layer off of P91 9% chrome in power plants, so they could test it for hardness, so they could do non-destructive testing on it. And that stuff creates such a layer on it that if you start putting a tiger pawl on it, or even if ceramic or whatnot, it's just gonna eat a disc. So at that point, we would go to a hard disc at that point. But that was a very particular case where they're trying to test main steam at a power plant for non-destructive testing. But if I'm prepping pipe to weld out, I'm grabbing a tiger pawl every time. That mill scale just comes off so smoothly and so consistently as you're pulling it towards you.
Yeah, if I have a lot of go ahead, Rick.
No, go ahead, Mike.
Yeah, I mean, there's different reasons. If I'm doing plate with a lot of mill scale on it and everything, and it's a lot, like let's say it's 20 feet, I gotta clean it off. I'm going for a hard rock, and I'm trying to get the most out of my wheel. I mean, I usually put this at the max angle because I want that corner to dig in really good. And I want to be, I mean, I don't work the whole thing at once. You want to start a little bit and just work that little bit, because if you're looking at the whole thing at once, it overwhelms you. You're like, okay, I'm just going to move back and forth and waste time. That's what it's going to do, waste your time. You're just going to do that. And I think I don't know, I just think you're going to get the most out of your wheel and, longest. That's my way how I do that with a hard rock. Then I usually, to make it look pretty, I flip over, like I said before, I flip over to the flat disc and everything. I mean, you got to do it on, you're going to use it on aluminum. You're going to be I like to use the flat disc on aluminum because you're trying to take this oxide layer off. It's actually got a higher temp. The coating has a higher temperature than your puddle. So you actually can't really burn through that coating. It's really hard. You're going to use a flapper wheel on aluminum. Steel, you're going to use a hard rock or a flapper disc. Depends who's operating the grinder. Titanium, there's usually no grinding wheel, usually involved on the prep. Let's see what else we got here. A36 steel, you're going to use it. Even pipe, the inside of a wheel, if you can, you're going to use a grinding. If it's a big pipe, you're going to use a pipe liner or a ceramic disc, hard rock. I'm trying to think of what else. You're even also going to bevel the pipe with a, let's say you're using, so let's say not this one. It's a taper though. Let's say you got a taper. I use this for, I don't know where the taper's at. Oh yeah, the taper. Let's say I'm using a taper. I like to bevel with this. Because if I'm doing a short bevel or not a really short, like a really steep degree, I'll use this because it's very aggressive, very fast when I'm beveling pipe too. But yeah. But
Well,
there's a
so
lot.
right, and again, right, a flap disc, because it's coated abrasive, right, and those flaps are designed to wear away, right, gives you a little bit more control, right, a little bit less vibration across the work surface, a little less possibility of gouging, right, or undercutting, right. But one of the cool things that both of you referenced was starting on a pull, right, pulling the disc into the work surface, right, and right, so critical. And one of the things that I always make a point to talk about is getting in the habit, because so often, right, when you plunge into a work surface, whatever work surface, right, and particularly if you're not familiar with the aggression of the product, familiar with the hardness of the workpiece, right, you can really do yourself a lot of damage, right, really get into that base metal and cause yourself a lot of rework.
Yeah, if you're I think when you're pushing, I'm not really seeing what I'm doing. My head's not right there paying attention to the metal. I got to pull and pay attention to it. You know what I mean? It's really critical in welding. I think you got to know what you're looking at and pay attention to it. I see a lot of people, you know what I mean, they got their elbow up to the sky basically and just digging into that metal with a hard rock, and they're just wearing that hard rock out, slowing themselves down, and they're burning up that wheel and grinder basically. I'm like, hey, see them numbers on that wheel? Lower that down a little bit. And, just lower it down and you'll go a lot faster. You'll be more accurate if you pull and work a little bit at a time. A lot of people, just burr in there. You can't do that. Bad.
So, and I mean, this is all great, right? And guys, like we've been talking about, I could talk with you guys, and I can't be in the same location, whether it's even virtually, without learning from both of you guys. But right, to just in the interest of time, right, to move on, I want to talk about the land, right? And I want I want to go right into, Mike, if you wouldn't mind talking about, right, your route and your grinding your starts and stops, the importance of getting in there and actually using, right, how you're using the wheel, what you're looking for, right, the techniques that you're using and the products you're using.
Yeah. Chad, bring up the wheel, bring up the plate where it's tacked together, and I started grinding up my tacks on the ends. I want to talk about that and have them understand what's going on here. To go a little bit before that, Chad.
A little bit before that. Okay.
So on the ends, well, you see me what I'm doing right there. I'm actually wire reeling, getting all the all the slag off from the weld. It's called a 6010, so it's going to produce a slag on top. Right there, I'm feathering out my stop where I stopped at. The reason you got to feather it out is because you're going to have a bad tie-in on the other side of your plate. It's your root, your back of your root. So if you don't have a good tie-in, you're not even going to get past your root inspection. They'll tell you to cut it back out. Regrind your bevel, retest, or give you new test plates. So it's very critical. That's why I use the pipeliner, because all the bevels are really tight. I can get in there without changing the bevel angle, without damaging it, and only focusing on one spot at a time. The reason, it's an 1/8 inch. I'm not going to use this 1/4 inch because I'm going to destroy that bevel. When you're using doing nuclear codes and very critical, you're not allowed to change that bevel. They'll look at you crazy and like, okay, you're not getting hired or anything. You're messing that bevel up. That bevel is engineered to a certain way to, to make it the strongest. Your weld's going to be the strongest this way. It's been all engineered by a welding inspector, a welding engineer. It has to be that way. You got to do it that way because it's, lives depend on it. But after I grind my stops and starts out, I basically take my wire wheel, kind of wire wheel the whole weld. Your root, it's called, that whole root. After that, I kind of inspect it all, make sure everything's good tie-in and everything. Me and Brian does a couple different ways. My way is I basically grind it until it's completely silver. So that's telling me in my head it's completely clean. I don't see no black. I don't have no lack of fusion. I'm using that pipeliner because I don't want to mess up my bevel or anything. The pipeliner is only 1/8 inch thick. And that's what I'm looking for on my root. Then after that, I go ahead and just start running.
Yeah, Chad, I'm sorry, Mike. I just wanted Chad to bring up that root grinding shot,
yeah,
right?
Yeah.
So that you
Yeah, so right there, I'm pointing out to my starts and restarts, stops and restarts. So see how I'm grinding that completely silver? That's your root right there. I like to get that completely silver. I'm avoiding any lack of fusion, any slag inclusion. Well, slag inclusion is from your, when you run a 6010, there's flux on it, and you trap that slag. You leave it on there and you run over it, it's trapped. You're not going to get it back out. You got to use a grinder to get it clean. And then I take the wire wheel and kind of buff it over all of it because I noticed with the encapsulated, I noticed I don't get wires all over my freaking shirt and my pants already, but it kind of polishes it a little bit, and I can take a flashlight and look, see if I have any indication. If you look right there, like about 3 inches down on your screen, there's actually a little black spot. That could be slag or lack of fusion in there. But obviously it passed, so it wasn't. But that's how I'm doing it, and I think it's the best way for me. But Brian, give your aspect how you do this. There's more than one way to do this.
Yeah, and it really depends on your experience, your background, what you've done. When I'm touching up my restarts or my tacks, I'm using this 332 grinding disc. It's for notching. You got one right there. And it allows me to get in. Now, when I was younger, when we'd be doing these preps, we'd be in there with a cutting disc and trying to use that properly, use that inside our bevel, and you start getting that deflection because this is the wrong tool for the job, and it's dangerous at that point. Now that this came out, this right here is the right tool, and you can touch up your starts and stops with precision. and then I start knocking down my high spots. I do leave the toe of my root pass in. I don't take it all the way down to shiny metal. But then I grab this pipeliner, and I'm going down the middle. I'm making sure the high spots are out, and I'm making sure all my slag's out. And I'm going to use this encapsulate every time. This thing, I've been hurt by a wire wheel from someone else running it, and this will be here every time. I'm actually implementing in my class right now because we have to clean our welds. But I don't chase it all the way down to bright shiny metal like Mike does. But that's been my experience. I've ran miles of pipe at this point, and I've learned my like tolerances of kind of what I can get away with. But if there is any question, if there's something I don't see, I'm grabbing that pipeline disc and getting it out of there every time.
Yeah, well, and real quick, just for some clarity, right, in that video that you saw of Mike running his route, right, and he actually switched wheels, although the second wheel that he ran was actually an encapsulated wire brush, right, and it looks black, but one of the things that you'd notice is that there was significantly less spark, and right, so I just wanted to bring up the point that it was two different products, right? First, he was going through with that pipeline wheel, that actual abrasive wheel to grind out and level things out. Then going in with the wire brush to clean. And you know, you referenced encapsulation, right? And just so everybody else, you know, knows, right, as compared to a conventional wire wheel with loose wires and knots, right? Encapsulation is a polymer coating that covers and encases all of those wires. Right, obviously, right, the number one complaint of any operator, any user, the biggest frustration is the fact that those wires will come loose. And the irony there is that wire brushes are designed for the tips to be doing the work, right? Think of like peening hammers, right? Shot peening. And a lot of times, right? And again, as wheels wear, but certainly as you're getting into those roots, a lot of times you're stressing those wires beyond their normal limit, right? And you think of folding a paper clip in opposite directions a couple of times and then snap, right? The wire will snap off. So by encapsulating those wires, we're able to still take advantage of those sharp tips, but not have any opportunity to overstress or bend those wires, right? This black coating is also an insulator from heat, so it'll also help to protect the wires, particularly in a multi-pass welding environment when you're potentially cleaning it while that weld is still hot. And then the other thing that I wanted to point out is the option of a dual nut brush, right? Like most conventional knot brushes will only have the nut on one side, but there is a significant benefit to being able to flip a wire brush, right, in order to maintain its aggression and its use, right? So any wire brush is dulling, those wire tips are starting to dull in the direction of rotation. So by being able to periodically flip a brush, you're now able to take advantage of the sharp edges in that opposite direction and maintain that high level of aggression, so you never feel like you need or want to push on the brush in order to get it to do work. So, you know, again, it's not necessarily right for everybody. It's not the answer for everybody. We're not looking to, but, you know, a lot of times, right, understanding that there are options out there that can make your life easier is 9/10 of the law, right?
Sure.
Yeah, that also that wheel, that encapsulated wheel, you know, I mean, if you're losing wires, you're slowing down, you're getting less cleaning. All them wires are staying inside there, and it's keeping you the same consistent cleaning. You're not losing, you know, I mean, you're not spending more time on the cleaning end when your wires are shooting out and hitting somebody or hitting your leg. You know what I mean? You're going to get slower because the wires are, you know what I mean, are disappearing. Them encapsulated ones, they're there, and you're going to keep consistent speed, and your time's going to be, you know what I mean, consistent. I mean, look how fast that is. That's pretty simple and easy.
Yeah, I imagine sooner than later these will probably become an industry standard, just as aspect.
Yeah, OSHA, yeah, definitely with OSHA, because there's a lot of people like walk around with their glasses down low, and I was like 30 feet from somebody, and I got hit right here on my side of my temple with one. Luckily, it wasn't my eye or nothing, but like, yeah, but people were right here, and I had a guy, he actually became a CWI with one eye, and it went into his eye. I did not know you could become a CWI with one eye. But yeah, that's why I think they're going to be standards.
Yeah.
So Chad, again, right in the interest of I mean, that, a lot of great stuff there. And again, guys, I appreciate it. Are there any questions, any topics, any discussion points that we can potentially hit? And again, I do want to be respectful of everybody's time and make sure that we have time to to stay on schedule. So anything that
we do.
can.
Yeah,
Awesome.
we have a couple questions here. So the first question is from Joe. And it says, just going back to the topic of guards, he says, guards are important, but what solutions do you have for people that continue to remove the guards other than firing them?
Other than firing?
Ooh.
Well, that's a tough one there. Very tough one.
Yeah.
Go ahead.
No, go ahead, Brian.
Okay, so this is something I have to deal with, and it's training. As a welding instructor, it comes back down to cause and effect, and you try to keep cause and effect out of my class at the college here, but sometimes you got to show them what can happen, and then you have to put something on the line. I mean, whatever that means. I get you don't want to fire the people, but that's safety, and that's not just putting their safety on the line. It's putting other people's safety on the line around them, and putting a little skin in the game on their side, whatever that means. I'm sure you can get creative with it, but retraining, cause and effect, and having them invest in that.
Yeah, I usually take them over, sit down on the computer and type in Google, grinding incidents or cutting incidents. And that enlightens them. They get their personality. Holy crap, I'm not losing my finger. No way. I see people actually, you see grinding wheels in people's head and they died. That usually changes their aspects because the wheel exploded and stuff and something happened. That guard's going to save your life and save someone from getting hurt.
That's a lot of times I see with my students is when I do that, because I do that, I have them Google search grinder injuries, and that starts off a lesson, and I get a lot of, well, they did something wrong. That's not me. And the more time you're in this industry, it's not the welding machines that hurt us. It's not the welding process. It's the grinders.
Yeah.
And they deserve a certain amount of respect. And that has to be implemented somehow. And that Joe, you asked that question. That's a tough one.
It's a great question, and it's a fair question. And right, to add on to everything that both of you guys said, right? The biggest things for me, and certainly, obviously, I don't know you, Joe, or anything about your facility or whatever, but right, like number one, the biggest challenge that I always have is again, right, when I'm having these conversations with guys, the number one challenge is it's always in the way. It's always in the way. And so by, again, effectively proving them wrong, right? Go to the application, working with them, working through it, talking to them about, considering the different angle of approach, understanding how to position, when to position, and where to position that guard, right? Is so many times, 9 times out of 10. And again, it's time consuming, and there's certainly no 100% one way answer to solving this. But, again, right, another way that I encourage it is that I never, ever, ever personally ever demonstrate a product without the guard in place and properly positioned and talking about it, right? Like one of the biggest things we all know is that everybody, particularly newer, right, students, right, Brian, everybody is learning from what they see their peers doing, right? The guy next to them and the guy in that next cell. So the more people that you can get in your facility using guards and appropriately using guards and demonstrating, right, just subliminally without having that effect, right, like it slowly starts to make the change. But I mean, you're 100% right. There's a mentality that they can get in the way, and so people just out of the box, they sometimes need that little bit of encouragement in order to just try it, right? Try it. And once you try it and you understand the positioning of it and where to put it, and again, right, so many times it's the ergonomics of it. How to is there a better way to attack this particular workpiece and come at it so that the interference isn't there? But I mean, when you think about it, if that guard is in the way, so too are your hands, the handle, right? Like so many other things are also interfering with the workpiece. Well before you get to the point where the guard is actually interfering.
Yeah. I mean, a lot of people don't even know what RPMs is. You know what I mean? Yeah. I mean, revolutions per minute. You know what I mean? That has to stay at max of that 10,000 or wherever it is, 14,000. Yeah. I mean, if you're taking that beyond it, you're going to explode it. I mean, let's say you put one, a 6-inch on a 4-inch, you're gonna explode it. A lot of people don't even know what RPMs is. You gotta actually enlighten them. And when I'm like grinding and stuff, I said I could get the results the same as you or better with the guard on, putting the right disc on, and I want to show you how to use it properly. I mean, I like to show everybody visually. I mean, I think that gets over explaining somebody better. I mean, some people might catch it by book smart because some people are like that, but a lot of welders I met is always visual. They want to visual see it. I mean, that's how it is.
To touch on that, when it's in the culture, like everything we build, we call it culture, at least in education. Once it's in the culture, it's hard to get out. You just gotta retrain, and really a grinding shield was never an option where I worked. It was always expected.
Yeah.
But rest assured, Joe, Weiler's got your back, right? And we will help you with the training side of things, right? We got an entire team that are focused on helping with, co-workers and operators understand the safe and effective use of abrasives and power tools. So, check us out on Weiler.com. You can get more information, and we can certainly set something up to have a deeper conversation about your specific situation. You said there were more questions, Chad.
Yeah, there's one more question in here. That's I probably also education related. So with all the options between grains and grits, ceramic, aluminum, zirconium, and types, what's the best way for young welders or people just getting into the industry selling to kind of get up to speed and understand what's available and what's the best abrasive to use?
The best abrasives? I mean, there's many types of abrasive. If I was going to sell to somebody, I would tell them, I would give a demonstration to them, like a live demonstration, and step it from beveling with a coarse wheel and show them what's the difference from a coarse to fine, and tell them what ceramic does, what zirconium does. Understanding all that, you need to look it up and read it. And and different industrials or industries will, like food, let's say I worked in food processing, you got to have everything finished, nothing like a sharp edge or nothing where food could get caught in. You're going to go to a finer grit and you're going to blend everything. You're going to use this type of wheel. If I got a high spot, I take this down really quick. Then right before I touch that material, a good material where I know I can't touch it, I usually switch over to a finer grit and just do like a little blend in and everything. But yeah, you gotta teach them and understand it.
Yeah, I mean, I'll touch on that because it's kind of been something I've recently gone through. Is not that I sell this stuff, but getting information and reading about this stuff and where it's cost effective, and getting your hands on it, really reading what it does and seeing firsthand. When I trying to figure out how to take down mill scale at a affordable rate at my college is kind of what dove me down that rabbit hole per se. And I read about the different abrasive types, aluminum oxide, zirconium, or ceramic, and I got some samples and I put it to the test essentially, and now I can talk with confidence on what I like. And now there might be a better, zirconium might be better than ceramic, but ceramic is at a price point that I can justify here at the college. And that's my personal opinion on that. That's not right or wrong. That's just my experience of what I've had. I've had this issue of cost effectiveness to getting, a certain outcome, and I had to kind of dive into it.
Yeah. You actually see a lot of people when you go, let's say you go to a shop and they're welding pipe or welding plate, and they're like, oh, just give me whatever wheel. They don't even know what wheel they don't even know nothing about the wheel. They just grab it and just go to work. You know what I mean? Like, I just like, hey, you know what these mean? Even if I don't, if like, let's say they don't, I go talk to them privately, go up to their workstation and kind of enlighten them and tell them what this means, what that means. I mean, if you're enlightening them and telling them all this stuff, you're helping yourself out and you're helping that company out and improving work. The work quality is going to be way better and faster. I mean, a lot of welders don't know this. I mean, I've been doing this for 15 years and I guarantee you a lot of people don't know still. I mean, you have to learn it and have to show them the right way and show them the correct methods. I mean, that's an accurate statement, I think.
Absolutely. And I think, again, and we're certainly, we don't have the answer for everything, but I mean, WeilerAbrasives.com, it really is a good resource for, a lot of different, we have videos on a lot of these different products that we talk to, right? Specific videos that show them in action, right? Give you that opportunity to see the various products. We also, in our literature section, have and make available, one of the things that we're committed to is the creation of field selection guides, right? And the ability to pare down some of these choices, right? We get it. There's a lot out there and there are a lot of options. And so, one of the things that I think you'll see certainly as part of the follow-up to this webinar is the availability of our researches, our field selection guides, our catalogs. We routinely get good feedback and continued feedback to improve and evolve and add more application specific and how to information regarding the pure use and application of a lot of these specific products. And so again, right, but at the end of the day, and Brian and Mike, right, are perfect examples, right? Here are two guys who are both totally committed and experienced at getting to the same goal, right? A complete failure-free career, and yet they use different products, right? Different options, different favorites. And so the biggest thing and the best way for you to really truly evaluate is to do, use some of these tools to track down what's best, what we're saying, what we might think is best for your application, but try them, right? Connect with us on social media, right? Reach out to us, all of us, right? I mean, Weld.com has taught me well more than they even know about how to weld, right? In a lot of these processes, and still, Mike, it'd still probably be embarrassed at a lot of my work, but I mean, I'm learning, right? And it's a resource. So, by the same leverage, right? A lot of these technologies, and by all means, reach out to us directly. We're here to help make recommendations based on specific applications, because there are a lot of different ways to get to the same goal. But based on, your specific preference, right? Your tool, the power of the tool. Ceramics are not necessarily the best answer for everybody, and we can talk about that, but in order to do that, right, we really do need to understand more about your specific goals and objectives in order to steer you down the right path.
Yeah, if you got someone like asking you a question, I did this other day, I didn't know what a type 28 was. So I took that part number. If you go to WeilerAbrasives.com, you take that part number of that wheel, you type it in. Let's say this one is 58090. You type it in, automatically it's going to show you what it's used for, what application, what type of metal, right off the bat. I mean, it's down to the nitty gritty, even gives you the SDS. I mean, you're going to find how to use it with a video. I mean, quick and easy. You can do all that information within a couple minutes, and you give your customer an accurate information, and it's not wrong either. I mean, that's the best way, I think, to me, if I don't know nothing about that wheel or anything. I mean, just sit there and look up what 40 to 90 degrees for or whatever. That's going to tell you what it's going to use for and why is it that way.
To that same point, right, we are open to your feedback, right? Tell us what it is that you specifically want, right? We're trying to manage and coordinate. We're looking to schedule W3s and more webinars like this through 2021. So by all means, right, reach out, let us know what it is that's most meaningful to you. Let us know what you'd like to see in future webinars, and we'd be happy to connect and pull together whatever we can do to help target and zero in on the right product for your needs.
Yeah, when you're talking to a welder, you need to know what type of material is working. What type of material is very important. That's your key thing. That's your starting point right there. All right. You got to know what that is. If you don't know what that is, hey, you know, I mean, good or call up Rick. Hey, I'm working with this. Send pictures or something. You have to know that right off the bat. What type of materials? Then you start getting in depth. Hey, do you have to do this? Are you allowed to do that? You know what I mean? Then it will basically take off from there, and you're going to help him out. I mean, got to know your materials. If you know your materials, you'll be at a good starting point, I think.
All right.
I appreciate it very
Good
much.
stuff.
You know, Chad, it looks like we're up against the top of the hour.
Yep. Yeah. So.
But you know, before you, again, I want to take a second and really, you know, thank and appreciate Mike and Brian for all of your input and your help. And yeah, again, I look forward to more of this certainly throughout next year. And again, you know, I always, every time I'm with you guys, I learn something. So, you know, really nice. And thanks again.
Likewise, you know, like me and Mike are welders. We're not experts on abrasives. This is just a tool that we use, and the more that we have this interaction, the more we learn about them, and the more we can get better at our jobs and passing that information along.
Yeah. I mean, I remember when Rick came here, it was this thin wheel right here. He said, hey, this one will get you through the metal faster because it's thinner. I'm like, what? Nuh-uh. And he actually showed me it. Then after, he surprised me, you don't have hardly no burr, or you don't have no burr at all. I'm like, what? I actually had to look it over. I didn't even believe him. I had to see it with my own eyes. I won't ever forget that, Rick. I thought that was pretty cool. Yeah. You probably don't even remember it. Jeez.
Oh, I remember it very well. I remember, you know, yeah. I mean, I won't bore everybody, but and sorry, Chad. You know, let's talk right again. Right here, some of the resources that we have available to everybody, and
Yeah.
a direct line for us.
So we'll be sending out a follow-up email to everybody who attended the webinar with some really great resources. We shared some video clips of that grinder versus no grinder video that Mike did on weld.com. So we're going to be sending out a link to that. We've identified 6 what we call must-have products for multi-pass welding. We're going to reveal those in that email as well. And we're going to share a couple articles that you know, that we think are valuable around abrasives and brushes when it comes to welding and weld cleaning. Also, if you need assistance from us, you know, our customer service team is always available. The number's right below. You know, and just wanted to, again, you know, express a big thank you for everybody who took the time to attend, and for Mike and Brian and Rick for sharing all this, you know, all this great knowledge. You know, I hope we can do it again soon.
Look forward to it.
Appreciate all of you.
Yeah, appreciate it.
Thank you very much.
Yeah, reach out to us. Don't be shy. I mean, there's no stupid question, guys. We're here. We're happy to help for sure.
Thanks, everybody.
Thanks again, everybody.
Bye.
Thanks, guys.